Okay, Mod 5, Lesson 6. Our lesson objective is this. I will be able to find the total volume of solid figures composed of two non-overlapping rectangular prisms. Our essential question, how can I find the total volume of solid figures composed of two non-overlapping rectangular prisms? Now this is the standard, MAFS 5 MD35B. There's about 3 sections of the standard, and this is B. Apply the formulas of volume equals length times width times height and volume equals base times height. Now remember, when it says base times height, that actually means the area of the base times height. So that's like saying the area of the base times how many layers. For rectangular prisms, define volumes of right rectangular prisms with whole number edge lengths in the context of solving real-world and mathematical problems. Now we're going to start off just by seeing the structure and solving for the volume. The last one I give you will actually be a word problem. All right, so this is what we've been working with. As we can see with this structure, get my pen. Here we have a length, we have a width, and we have a height. So we know that just like the formulas up here, volume equals length times width times height. So we just plug them in. We see the length is 3 meters times the width, which was 2 meters, times the height, which is 7 meters. And then we can multiply them, which we end up with 6 meters squared, which is actually now this formula is into the base, times 7 meters, which gives us a whole volume of 42 meters cubed. So we know the area of this total cuboid here equals 42 meters cubed. Now, that's nothing new. That's what we've been doing. But let's take a look at what. All right, so let's look at a compound prism now. Now, if you notice, instead of just having one prism, we actually have one stacked on top of the other. And what we're going to do for the first one, we're actually going to separate the prism. Okay. Now, if you notice for this first one, volume equals length times width times height. The length is 6 inches, the width is 5 inches, and the height is 4 inches. So 6 times 5 gives us 30 inches squared. That's because it's giving us the base area, times 4 inches, which is going to give us 120 inches cubed. So we know this volume is 120 inches cubed. Now let's come up to the top. Now I have volume equals length times width times height. Well, I can see right now my length is 3 inches. I don't see a width, but I see the height is 2 inches. So I'm looking for this width right here. Well, if I look down to the other structure here, and when it was stacked over here, you can see that the structure is the same size width all the way through. So I know that this, let me find my pen, or there it is 5 inches. So now I can go ahead and find the volume for that prism. That's going to be 15 inches squared times 2 inches, which gives us 30 inches cubed. So this one's 30 inches cubed. So when we add them together, we have 120 inches cubed, and we have 30 inches cubed. We know the total volume of this structure is 150 inches cubed. All right, let's try one this time without separating it apart. And I'm going to label this one Prism A, and this one here is going to be Prism B. Now Prism A, if I go volume equals length times width times height, I can see that the length is 6 meters. I can see the width is 2 meters. And I can see the height, well, when I'm looking here on this height, I don't see it because I see a combined height of the two structures. But if I come to the opposite side, I can see the height of the structure is 2 meters. So I'm going to replace this h here with 2 meters. So now we have 6 times 2, which is 12 meters squared, times 2 meters. So now we have 24 meters cubed for prism A. So 24 meters cubed. Now let's look at prism B. And we know volume equals length times width times height again. The length I do not see. But what I can see is the total length here is 6 meters. If I look on top here, it's showing me from here to here is 4 meters. So I know this section right here has to be 2 meters to add up to the total on the bottom. So I have 2 meters in length times width. Width, we can see on the if I'm looking here, right here, I have no designation. But if I look down to the bottom prism, I can see its width was 2 meters. And you can see visually that it's exactly the same as the bottom. So we're going to end up with 2 meters for the width. Now the height. Now this is showing us a total height of 4 meters. But we already saw that the prism A was 2 meters high. So if from here to here is 2 meters, that means the top one also has to be 2 meters for a total of 4. So now we have all 3 dimensions. And we go 2 times 2, which is 4 meters squared, times 2 meters, and we end up with 8 meters cubed. So for the total volume, we have 24 meters cubed plus 8 meters cubed, and we end up with 32 meters cubed total volume. So all we did was we separated it, and instead of actually separating, we transferred the common measurements to the faces of the cube, so we had our 3 dimensions to solve for volume. All right. Now let's take a look. This is a word problem. It says 2 rectangular prisms have a combined volume of 135 cubic meters. Prism A has double the volume of prism B. The first one says, what is the volume of prism B? Now, a lot of people are going to look at that and say, there's not enough information given. All right, well, let's take a tape diagram first, and let's see if we have enough information. We know that the total volume is 135 meters cubed. And it says prism A has double the volume of prism B. So I'm going to split it into 3 sections because it's double the volume. And I know here is prism A, and here is prism B. Now I can see by this, if I want to solve for what each one of these sections are, I'm going to divide. It's 135 divided by 3 sections. 3 goes into 13 4 times. 3 times 4 is 12. We get 1 back. We bring down our 5. 3 will go into 15 5 times. 5 times 3 is 15. And we have no remainder. So we know each one of these sections is 45 meters cubed. So what is the volume of each prism? So prism A is equal to 45 meters cubed plus 45 meters cubed. When I add those together, I'm going to get 90 meters cubed. This would be a 3, not a 2. Now for prism B, we can see that I can write it over here, because there's only one section. Prism B is actually 45 meters cubed. Now on B, it says if face of a prism A is 10 meters, what is the height? Well, I'm going to go ahead and draw me a quick 3D representation here so I can label it like it says. So there's my prism A, and it says the area, one face of the prism has an area of 10 square meters. So since it's wanting me to find the height, I'm going to take this as being 10 meters squared. That's the area of this top section right here. Now I know that volume equals length times width times height, or the volume equals area of a base times height. So this is the formula I'm using right now. So volume equals area of a base times height. And we know the height is 10 meters. Excuse me. I know the area is 10 meters squared. Okay. Let me erase that and put it back in the right place. So the area of the face here is 10 meters squared times height. And we know that prism A from above was 90 meters cubed. So I'm looking at what times 10 equals 90 meters cubed. Well, I can see that 90 meters cubed times 10 meters cubed, I would have to multiply 9 to get 90. So that ended up being 9 meters. So the height equals 9 meters. Now, if you notice, this section right here we did with the tape diagram, we've been doing that in our homeworks, and it looked like the same strategy worked here. Okay, so the hardest part of this part of the standard is being able to identify the lengths of the different cube. Okay, so when you have the cube, and let's say it's stacked on top of another cube, sometimes you're going to have to look at the different sides to find out. Let's say I had the total length on this one here was 5, and this part here was only 3. That means this side here would have to be 2 because they're stacked on top of each other. Okay, so that's the hardest part. You know how to solve for volume. Now you just got to be able to find the side lengths. Okay, all right, see you in class.